Hello everyone, welcome to Robert Morris University, Chapter 1, Lesson 7. This is Brianne Pernick. In this lesson, we are going to work on identifying like terms and combining like terms. Now, throughout the sections that we have worked on so far, you have heard me talk about these vocabulary words and even explain them a little bit. The reason that we have had to talk about them and explain them a little bit so far is because they are used so frequently throughout pre-algebra as well as algebra, and they are a prerequisite knowledge that you have needed up until this point, but they weren't introduced yet in our curriculum. A little bit backwards, right? Now, before we actually discuss what a like term is, I do want to review with you what a term is, because I do feel like that is useful for us to know. Now, terms are the individual pieces of an expression that are separated by plus and minus signs. When we put our terms together to make a mathematical expression, we read each term using addition and subtraction. For example, if we look at this expression, we would say 2x cubed plus 5x squared minus 6x plus 9. However, if we separate each one of those terms out according to their plus and minus signs, we will see that there are how many actual terms in this expression? What do you think? Well, keep in mind that I said that we're going to separate them according to their plus and minus signs. So the first term is a positive term because there's nothing in front of it. The second term is also positive because there's a plus sign directly in front of it. The second term is the negative 6x. And the last term is the positive 9. So you can see that there were 4 terms in that expression, and they were separated by their plus and minus signs. Now that we know what a term is, let's start talking about like terms. Like terms need to be thought of as like quantities, because I should say because they're like, we can combine them together to simplify our expression. Okay, plain old numbers such as the term of 9 that we had in our previous example should always be considered like terms, and you should always combine them together using addition and subtraction as noted by the sign in front of that term. Okay, now I say right here in this note that like terms need to be thought of as like quantities for a reason. When you have a 2x, a 3x, a 7x, think of that as something concrete rather than an abstract x. Think of it like having 2 apples, 3 apples, and 7 apples. How many apples do we have altogether? 2 plus 3 is 5, plus 7 is 12. We have 12 apples. If you think of them as quantities rather than terms, it makes that abstract concept a little bit more concrete for you and perhaps a little bit more easy to understand. Similarly, if you think about having your x's, which were our apples, and y's maybe as mugs, like coffee mugs, then you can think about how different those two items are. I'm not going to pick up all of my apples and then pick up my mugs and put them in the same basket. That wouldn't make sense to do that. So that is what the concept of like terms is doing. You are picking up all of your items that are the same and combining them together so that your expression can be more simplified and nicer to look at. That's what's happening there. Okay? Now, in order for terms to be considered like terms, when the variables are involved, every single thing about the variable portion of that term has to be identical. So it has to have the same variable or variables, and it has to have exactly the same exponent or exponents if that variable has more, or if that term, has more than one variable component to it. Okay, so let's look at some examples here. Let's simply list the like terms in the following expressions. I'd like you guys to take a stab at this first. So go ahead through A, B, and C. Go ahead and list which terms you think are the like terms in those expressions. So pause the recording, list them, and then we'll come back together here when you're done and check it. Okay, at this point, you should have paused the recording and listed the like terms in A, B, and C. So let's see how you did here. In letter A, the terms that were like terms were 5x and 6x. There were no other terms in that example that were like terms. In letter B, the only terms that were like terms were 4a and negative 9a. Please remember that the sign that is in front of the term belongs to the term, and you have to bring it down with it everywhere that it goes because it's part of it. Okay? And in letter C, we do have two sets of like terms. The first set is 7m squared and negative 3m squared, because those ones have an m and a squared with them. Remember, everything about the variable as well as the exponent must be identical. And then the second set is the positive 10m and the negative m. Hopefully you guys did okay on that. All right. If you have questions, please make sure that you let me know, because this is an extremely important concept in algebra, and we need to make sure that you guys can combine like terms. Now at this point, we are going to move on and start actually combining these like terms. And at this point, we are going to revert back to our example about the apples. Okay. Now, I did leave out my little coefficient here for this. I had 5 apples written here. Sorry about that. Now, add that to your notes. If you have 4 apples plus 9 apples, how many apples do you have? We know from probably first grade that 4 apples plus 5 apples in our basket is going to make 9 apples. That's simple addition, okay? Combining like terms works in exactly the same way that combining the apples did. Okay, you need to remember that like terms are nothing more than like quantities, similar to those apples, similar to those coffee mugs. Maybe you like oranges, bananas, something, okay, whatever you want to think of them as. It would be like putting all of the X's or all of the Y's into one fruit bowl and combining them up and making your expression more simple. So 4x plus 5x makes 9x. That's all we're doing there, is combining our x's. Nothing changes about that variable. We're just simply combining them and putting them together. So let's look at some examples here and practice this. For letter A, we have negative 4x squared plus x squared, or 8x squared, excuse me. They are like terms, we just want to combine them, so we're going to use the rules of addition. Negative 4 plus 8 makes 4x squared. We're just combining them. We're putting all of our apples into a bowl. If you have 8 and you take away 4, you're left with 4. Letter B, 13n to the fourth minus 8n to the fourth. 13 minus 8 gives us 5n to the fourths. Letter C, why don't you guys go ahead and try this one on your own. Pause the recording. When you're ready, press play again and we'll go ahead and check letter C together. Okay, for letter C, you should have started by saying that 7 plus 6 makes 13y's. 13y's, take away 3y's, is going to leave us with 10y's. Now, if you did all of that math in one step, that's perfectly fine. Okay, perfectly fine if you did all that math in one step. Letter D. Letter D. Go ahead, try that one on your own. Pause the recording and then we'll go over the answer. Okay, by now you should have completed letter D, and we will see here that we have negative 3a cubed plus 6a cubed is going to give us 3a cubed minus a cubed. So 3 minus 1 gives us 2a cubed. Again, if you did all of that math in one step because you're doing that math either on your calculator or in your head, that would be okay as well. Now, letter E, you're going to notice that you have 3 different sets of terms. So you need to identify which ones are like terms and which ones are not. Please go ahead and try letter E. When you are ready, we will go over the answer together. Okay, at this point you should have solved letter E, and when you did such, you should have seen that you only have one term that contains an S. Since you only had one term that contains an S, it cannot be simplified with anything else, so we're simply going to bring it down. Now moving on to the T's, we have negative 4t plus 2t. Those are like terms, so they can be combined. Negative 4 plus 2 does make negative 2t. Lastly, we have a constant. It is the only constant in our equation, so since we have no other constants to combine it with, we are simply going to bring it down. Please keep in mind that in an algebraic expression, your variables should always be written in alphabetical order. Letter F. Letter F. Go ahead and give that one a shot. Pause the recording. When you're ready, we'll be here to go over the answer. Okay, by now you should have completed letter F, and we are ready to go ahead and go over the answer together. Like terms mean that every single thing about the variable and the exponents match. So as you are scanning your expression for like terms, the first term you come to is a c squared d. That means that in order to find another like term, you need to look for a c squared d. And we do find one right there in the negative 7c squared d. Every single thing about those variables and exponents must match. They must be mirror images of each other. So we can go ahead and combine those. We have 2 minus 7, which makes negative 5, C squared D. I like to cross out my terms once I have used them so that I know I have taken care of them and then I've brought them down, and it helps to see what's remaining. So the next term we have is a CD squared, and then we have another CD squared. So we can go ahead and add those together. 5 plus 1 makes 6 CD squared. At this point, we have simplified our expression. There's nothing further that we can do, and we are now ready for letter G. Go ahead and pause the recording. As soon as you're ready, we can come back together and check your answer. Okay, as you are looking at letter G, you will notice that as you look for another x squared y, there are none. So we can simply bring 6x squared y down into our next line. Next, you are going to look for a 9x, or excuse me, just an xy. There are none. So we're going to bring that one down. Then we're going to look for an x squared y squared. There are none. So we're going to bring that term down. That leaves us with just the same exact expression that we started with. Sometimes this happens. It cannot be simplified because there were no like terms. In a situation like this, it would have been okay to simply write cannot be simplified. Letter H. Go ahead and solve letter H for me. Whenever you are ready, please unpause the recording and we'll go over the answer together. Okay, at this point you should have solved letter H. Let's start to go through this one, and we're going to look at the problem. The first thing that you do in a situation like this is start with the letter that comes first in the alphabet. So we are going to start with the letter C. We have negative 8C and 2C. So negative 8 plus 2 makes negative 6C. I'm going to cross out my C's so I know that I've used them. Then I'm going to move on at this point to my D's. I'll explain why in a moment. We have 3D plus 5D, which makes 8D. Cross those out. And lastly, I have D squareds. So I have 1D squared minus 3D squared, which makes negative 2D squared. Now you may have remembered earlier in the lesson that I said that your variables should always be in, your exponents should always be in descending order, meaning that we start with the biggest power and go down. Well, that's not what I've done here, right? My exponents go 1, 1, 2. Why did I do that? Well, the reason being is because we have two different variables, and we always start with the variable that comes first according to the alphabet. So that variable would be the one that goes in descending order. After that, our second variable would go in ascending order. So the D would have to go in order from smallest exponent to biggest. Moving on to letter I. This one is a fractional example. Please go ahead and pause the recording. Take a minute to solve it, and then we'll come back together. Okay, for this particular example, the first thing that we want to do is combine our C's. But before we can combine our C's, we do need to get a common denominator. So for these fractions, since we have a denominator of 3 and 2, I would change them to a denominator of a 6. So for the first fraction, in order to get to a 6, we would multiply 3 by 2. So we're going to multiply the 2 by 2. So 2 times 2 makes 4. So we have negative 4c plus, then we want to change the 1/2 to a denominator of 6. So 2 times 3 made 6. 1 times 3 will make 3 C's. Now, I'm going to leave those the same for just a moment, and let's work on our D's. In order to combine 2D minus 4/5, we will have to get a common denominator. So this at this point is a 2 over 1, and we will have to change them to a denominator of 5. So in order to turn a 1 into a 5, we will multiply by 5. So 2 times 5 makes 10D minus, because the 4/5 is a minus, this one does not have to change at all. We're just going to leave it 4/5. So now at this point we do have fractions that have common denominators for our like terms, and we are able to combine them. So we're just simply going to add and subtract as we normally would. So we have negative 4 plus 3, which leaves us with a negative 1/6 C. And for my D's, I have 10 minus 4, which gives me a 6/5 D. Now, usually I tell you never leave a fraction as an improper fraction and always simplify it. But in a case like this where you have multiple variables and they are in an expression string like this, please leave them as improper, because you never know, at some point you are going to have to multiply, maybe divide with that type of fraction, and you cannot multiply a fraction if it's in the form of a mixed number. So save yourself a step, leave it improper so that you can work with it in your future. Okay, last example requires you to distribute, combine like terms, and simplify. Go ahead and pause the recording, solve this last example, and then we'll come back together. Okay, at this point you should have solved letter J and you should be ready to go over the answer with me. So for letter J, you will notice that in our first quantity we have 2y and 3. We cannot combine anything within those parentheses, so we must distribute. So we are going to take our 7a and multiply it to both the 2y and the negative 3. So 7a times 2y makes 14ay, and 7a times negative 3 makes negative 21a. Now on the second part of this problem, we have a 5ay and a negative 4a inside the parentheses. Again, those cannot be combined, so we are going to be distributing a negative 3 into that quantity. So we have negative 3 times 5ay, which makes negative 15ay, and we have negative 3 times negative 4a, which makes a positive 12a. Please watch your signs through the distributing and your multiplication. It is very important that you have your accuracy of your signs, or else your problem will not be correct. At this point, you are ready to combine your like terms. So we're going to start with our ay's. We have 14ay and negative 15ay. 14 minus 15 will give us a negative 1ay, so we're just going to write negative ay. The 1 is not necessary and it's not appropriate to put it there. And then lastly, we have negative 21a plus 12a. Negative 21 plus 12 is negative 9a, and there is our final answer. If you guys have any questions about anything that we went over in this lesson, please contact me and let me know. I will be more than happy to help you out. Thank you. Hello everyone, welcome to Chapter 1, Lesson 8. This is Brianne Pernick for Robert Morris University Math 0900. In this lesson, we are going to work on evaluating algebraic expressions for a specific value, as well as evaluating a formula by substituting values. So the main key concept that we're going to focus on throughout this entire lesson is using substitution to plug in values for a specific variable. So there are some main vocabulary words that I do want you to make sure that you do understand before the end of the lesson. So at the end of the lesson, please go over this list and make sure that you understand what each one of these terms are. So moving on, the first thing that we're going to do here is work on evaluating an algebraic expression for a specific value. Now, in all the examples that we've done so far, we worked on combining like terms and simplifying that expression, and we just left the answer as it was. Sometimes you are going to be given a specific value for your variable and be asked to evaluate your expression for that value. So in order for you to be able to do this, you have to be able to correctly substitute in a value for that variable. In other words, what we're going to be doing is replacing our variable or variables, depending on the problem, with the given numerical value that we were provided in each of our problems. So let's take a look at our first set of examples here. Our first example is letter A, and in letter A, we're being told to evaluate by replacing our x with -4. So we're simply going to make that substitution. Everywhere that we have an x, we are going to write -4. So we have 6 plus 3 times -4. Note how I'm using parentheses for multiplication as well as to show separation between my 3 and my -4. It is easier to use the parentheses to show that multiplication so that you don't have to worry about using a dot next to a negative and wondering, is that subtraction? Did I put a dot there by accident? What am I doing there? If you have the parenthesis directly next to the parenthesis, then you know right away that that is multiplication. So from here, you're going to use the order of operations and start with your multiplication. So 3 times -4 is going to be -12. So we're going to write our expression as 6 minus 12. And then lastly, take care of that subtraction. So 6 minus 12 is -6. Moving on to letter B, we are being asked to replace our x with a -6. So we're going to go ahead and substitute in that value. So I have 2/3 times -6 minus 5. Again, notice that I used parentheses to show that multiplication as well as to separate my negative sign so that it's just a little bit more organized. You can tell just by looking at it that you're going to be taking care of that with multiplication. So I'm going to write this as a fraction so that we can clearly see that we have multiplication of two fractions, and I'm going to check for cross-canceling. 2 and 1 cannot be cross-canceled, but 3 and 6 can. My 3 will become a 1, my 6 will become a 2. And now we can straight multiply. I have a positive fraction and a negative, so a positive times a negative will always be a negative. 2 times 2 is 4, and 1 times 1 is 1. So since I have a whole number, or not a whole number, but an integer, excuse me. Since I have an integer, I'm just going to leave it as a -4, and I'm going to bring down my -5. Now I have -4 minus 5. When your signs are the same, you keep the sign and add the numbers, so we have -9. -9. Now we have some more examples here, and these examples do contain some exponents. They do contain some exponents. So let me show you how these are going to work. When you have an exponent and you're working with substitution, it's very important that you utilize your parentheses and the order of operations. Please note that we're being asked to substitute in a -3 according to our directions up here. So I started by substituting in that -3, and I had to put in the parentheses, number 1, to show the separation between the multiplication of the 5 and the -3, and also because I have a negative base that is being raised to a power of 2. You need to remember back to that exponent lesson that we did already in week 2, where we learned that when you have a negative base, it must be in parentheses, or else that exponent does not belong to that negative sign. Okay, so now following order of operations, we can take care of that exponent. We know that if the power is even, our answer will be positive. So 3 to the second power is 9. So 5 times 9 becomes 45. So now in letter D, this one is an interesting problem because we have 2x as our base, and that is being raised to the second power. So I'm going to actually introduce a set of brackets, and I will show you why in a second here. And I'm going to have 2 times -3 raised to the second power. The reason that I used brackets was just to show further separation, to let you know as you're looking at that problem that you do have an inside set of parentheses, because you always start with your innermost grouping symbol and work your way out. So the first thing we're going to do is the multiplication that is inside the brackets. So we're going to have 2 times -3, which is -6, and I have to keep that inside a grouping symbol because that is my base and it's raised to the second power. If I have an even power, my answer will be positive. I don't care about that negative anymore. So 6 times 6 is 36. Okay. Why don't you guys go ahead and try letter E. Pause the recording. As soon as you're ready, we can come back together and solve it together. I'd just like you to give it a try for me. Okay, at this point, everybody should have completed letter E, and you should be ready to go over the answers with me. So right now, what we're going to do is we are going to plug in -1 everywhere that we have a y. So we have 2 times -1 minus 5 times -1 to the second power. Please note that I did use parentheses everywhere that I substituted in that -1 to show the separation with the multiplication, as well as to show that my -1 is a base. Order of operations says that I need to do that exponent first, so everything else is just going to come on down into my next line. And when I have an even power, my answer is positive, so that leaves me with 5 times 1. Now I can take care of any multiplication or division in my problem. So 2 times -1 is -2. Negative 5 times 1 is negative 5. Now I have negative 2 minus 5. When the signs are the same, we are simply going to keep the sign and add the numbers. So negative 2, or we'll keep the sign, add the numbers. Sorry, 2 plus 5 is 7. Please excuse me. Negative 7 is our answer there. Okay, now we have letter F. We are going to be substituting for A and B here in this problem. Go ahead, pause the recording, try this one on your own. When you're ready, please hit play and we will go ahead together and solve it. Okay, at this point, everybody should have solved letter F and you should be ready to go over the answers with me. In this problem, we are substituting in 1/2 for A and 1/3 for B. So for the first problem here, we want to have 1/2 as our base. So we have 1/2 squared plus 3 times 1/2 times 1/3 minus 2 times 1/2 minus 4. Now, as we're going through this problem, please remember what I taught you about raising a fraction to a power. We are going to square both the numerator and the denominator. So 1 times 1 is 1. 2 times 2 is 4. Moving on to the next set of things to do here. Since we've taken care of the exponent, I can now worry about any multiplication or division. Now these fractions are all being multiplied together. I'm going to rewrite my 3 as a 3/1 and check for cross canceling. As we look at all of the numerators and denominators, you might see that the 3 and 3 will cancel. So now as you do your multiplication, you have 1 times 1 times 1 and 1 times 2 times 1. So that whole middle cluster just turned into a 1/2. Moving on, you have a 2/1 times a 1/2. Utilize your cross canceling. Your 2 and your 2 will cancel. So now you have a 1 times 1 and a 1 times 1. So we just have a minus 1. And then we're going to bring down our 4. Now we have two fractions that we need to get like denominators for, and we can use a denominator of 4. So I'm going to bring down my 1/4 and work on changing my 1/2 to a fraction that has a denominator of 4. 2 times 2 made 4, so 1 times 2 is 2. And I'm going to go ahead and combine my -1 and my -4 to make -5. 1/4 plus 2/4 is 3/4 minus 5. I can now turn my 5 into a fraction that has a denominator of 4, since that was a 5/1. 1 times 4 made 4, so 5 times 4 is 20. 3 minus 20 is -17/4. And you can then turn that into an improper fraction by setting up your division problem. How many times will, that's a 17, how many times will 4 go into 17? It will go in 4 times with 1 left over, so your answer will be -4 and 1/4 as our final answer there. Our next objective for this section is for us to be able to evaluate a formula by substituting values. So you will see that I have provided you with a great formula sheet here, just in case you have not just in case you do not know all of the formulas. Please make good use of this formula sheet, and remember that everything that you do in this class for me is open notebook and open book, so this would be a really good reference for you. So our first example that we have here is asking us to find the area of a triangle that has a base of 9 inches and an altitude of 20. Now, what's important for you to know here is that the altitude is very similar to the height of a triangle. It's going to come from the tip top of the triangle all the way down to the base, and it's going to make that very important right angle with the base there. That's what the altitude is. And we need to know the altitude of the triangle because the formula of a triangle is 1/2 base times height. And since the altitude and the height are the same thing, we need to know the altitude. Now we were given the base and we were given the altitude, which is the height, so we can go ahead and plug into that formula for a triangle. So we're going to write A equals 1/2 times 9 times 20. Now, as you guys are doing this, please remember that your multiplication is commutative. And what that means is that you're allowed to multiply in any order without affecting your answer. So as you are doing this problem, look for shortcuts, such as 1/2 of 20 is 10, and then 10 times 9 makes 90 square inches. Okay? Please also remember that when you are solving problems like this, you must label your answer with an appropriate label. If you do not label your answers, you will miss points on homework, tests, quizzes, and the final exam. So please make sure that you are labeling this type of problem. Letter B. We are finding the area of a circle when the radius is 5 centimeters. So let's just review real quick that when we have a circle, we have the center of a circle and the radius comes out from the center. If you have a piece of the circle that goes the whole way across the circle through the center, that is your diameter. Okay, so just so you know that those vocabulary words there. Now the formula to find the area of your circle is A equals pi r squared. And you can use either the pi button on your calculator or 3.14. And then we're going to substitute in our radius of 5 and solve. Why don't you guys go ahead, take a minute, solve that down, and come back together to make sure you have the right answer. Okay, at this point you should have finished problem B, and you should have had 3.14 times 25. Whenever you took care of that multiplication, you should have had 7.96 centimeters squared. Letter C. The formula C equals 5/9 times the quantity F minus 32 converts to degrees Celsius when given degrees Fahrenheit. What is the Celsius temperature when Fahrenheit is 5 degrees? Please take a minute, solve letter C, and when you're ready, we will come back together and check our answers. Okay, by now everybody should have had an opportunity to solve this problem. We're going to go over it together. You always start by writing your formula. This does help you to keep your problem organized and to know what exactly you need to substitute in. So at this point, we're going to substitute in the 5 for 5 degrees Fahrenheit. Take care of the math that's in the parentheses. So 5 minus 32 is 27. We're going to write our 27 over 1 and check for cross-canceling. We can cross-cancel. 9 will become a 1, 27 will become a 3. The last step here, and I'm just going to write over here at this point, is to straight multiply. So 5 times 3 makes 15. 1 times 1 makes 1. So that means that the degrees Celsius will be 15. So for this problem, I would write 15 degrees Celsius just so that my viewer or my teacher knows that I know what I'm talking about there. Okay. Letter D. A recent oil spill of a tanker off the Mediterranean coast had a radius of 5,000 meters and a uniform thickness of 0.002 meters. How many cubic meters of oil were contained in the spill? Now, the volume of a right circular cylinder is V equals pi r squared h. And if this is hard for you guys to picture, what you need to think about is that oil is laying on top of the sea. And even though it's very, very, very thin, it's still going to be a cylinder. And the height of that cylinder is the 0.002 meters. Okay, that's the thickness of that cylinder of oil that's laying on top of that coast or of that sea. That's the thickness of the oil spill, and it's in the shape of a cylinder. Okay, so think about that. Go ahead and plug in to the formula, solve it down, and then we'll come back together in just a few minutes when you're done and check to make sure that you got the right answer. Okay, at this point, everybody should have had an opportunity to solve this problem. We are working with the formula to find the volume of a cylinder because our oil spill is in the shape of a very, very, very thin cylinder. So we have V equals pi times the radius, which we were told is 5,000 squared, times the height, which is 0.002. It's a very, very, very thin oil spill, obviously. So the first thing that we do here is take care of our exponents. So 5,000 squared is 25 million. And the last thing you're going to do is multiply your 0.002 times your 25 million times 3.14. When you do all of that multiplication, you should have had 157,000 meters cubed. That is the volume of the oil spill. That is the volume of the oil spill. Okay, we have one last problem that we are going to work on, and this problem is going to allow us to convert from miles per hour to meters per hour so that we can know whether or not we're speeding. So when driving in Canada or Mexico, we must observe the speed limits posted in kilometers per hour. A formula that will convert R, which is the miles per hour, to K, which is kilometers per hour, is K equals 1.61 R. The posted speed limit in a Canadian town is 50 kilometers per hour. If you are traveling at 30 miles per hour, are you speeding? Take a minute, solve this problem, and figure out whether or not you're speeding. Pause it. When you're ready, come back together. Okay, at this point, everyone should have had an opportunity to solve this problem, and we should be ready to check it. Now keep in mind that we were given miles per hour, which they told us is represented by the letter R. That means that we are solving for K, which is the kilometers per hour. So we are going to plug in for R. When we multiply 1.61 times 30, we find that we are traveling at 48.3 kilometers per hour. So we are not speeding. We are not speeding. If you have any questions about anything that we have covered during this lesson, please feel free to contact me and let me know. As always, I will be more than happy to help you and go over anything with you. Thank you.